which can be melted to a liquid and remolded as it returns to a solid state. It is formed by a monomer named ethene. There are different types of polythene, namely HDPE, which is high-density polythene, and LDPE, which is low-density polythene. HDPE is used to produce hard hats, detergent bottles, natural gas and water distribution piping, and food storage container. Meanwhile, plastic bags, film wraps, cables insulation, and for general purposes uses LDPE to produce them. The production of polythene consists of 3 stages, which includes production of naphtha from crude oil, production of ethene from naphtha, and production of polythene. Stage 1. Production of naphtha from crude oil. Fractional distillation of crude oils use boiling points to separate the different parts of the crude oil. The crude oil is heated to about 350 degrees Celsius. The vapor of the oil cools to about 75 to 190 degrees Celsius and condenses to produce naphtha. Naphtha has about 20 to 40% of its component in crude oil, with 6 to 10 carbon atoms in its molecule fraction.
Initially, feed in liquid or gas form are transported by tankers and pipelines from a refinery or gas treatment complex. These hydrocarbons are then routed to a steam cracker, which is the main unit of a petrochemical complex. This unit is composed perhaps sectional with several furnaces for the thermal cracking. It's a technique proprietary technology using either Technip or Stoll and Webster technology. Hydrocarbons are preheated in the convection oil and then cracked in the radiation zone at a temperature as high as 150 degrees Celsius or approximately 1550 degrees Fahrenheit. Resulting gases are then sent to a clean section to recover the heavy components in distillation columns. Resulting gas is then cooled down to an ambient temperature prior to being sent to the compressor. Pressure required for separation is around 35 bars, 515 psig. Finally, proprietary cryogenic separation technology is used to separate the ethylene and propylene from the other products. Ethylene at low temperature is then purified in a column standing 80 meters or 260 feet tall. 99 with 95% pure ethylene comes out in liquid form to be either stored in cryogenic tanks or shipped by pipelines until it's transformed into a wide range of products.
Ethene made from naphtha from the second stage is first compressed. The gas is cooled and is passed through a reaction vessel where an initiator starts a polymerization to form polyethylene. Unreacted ethene is separated and recycled to the compressor. The polymer is extruded and cut into pellets. Ethene is compressed to a pressure of 1500 atmosphere by the compressors. Compressing a gas heats it up, so the compressed ethene must be cooled. Next to the compressor are pipes where the gas is cooled. This pipe is called cooling pipe. Hot gas flows into the center of the pipe while cooling water flows into the opposite direction in the outer pipe. The cooled and compressed ethene is now a dense gas which is almost like a liquid. Now, initiators goes to the gas stream as it enters reaction vessel. At 160 degrees and 1500 atmosphere, polymerization occurs in this reaction vessel. Ethene gas is fed in the top of the vessel, then initiators are added. Around 20% of ethene are converted into polyethylene in this vessel. The unreacted ethene and polyethylene mixture is passed through the first of 2 separation vessels. In the first separation vessel, unreacted ethene is removed and recycled. At the second stage of separation, additives such as antioxidant and stabilizers are added. This is an extruder where the molten ethene is pushed through a die of desired shape, and in this case, a pellet. The pellets are then transferred to a decanter centrifuge where most of the water is removed. They then pass through a drying tower where, after being screened by size, water and remaining ethene are removed using a stream of air. And this is the final product of polyethylene pellets.
Sustainability of polyethylene. The first is easy to move. Second is a wide processing window. Third is tough. Fourth is good chemical resistant. Fifth, good food proof. Sixth, good UV stability and resistant to harsh environment. It also have a good global availability. Easy to grind. Low cost. Low energy consumption. In total, it is relatively competitively priced. It is widely available, non-toxic, versatile. There are some limitations of polyethylene. They are soft, easy to scratch, not stiff, low resistance to high temperature, low melting point. For workplace exposure part, those who are working with HDPE could be exposed during maintenance, sampling, testing, or other procedures. Good housekeeping practice and control of resin dust are necessary for safe handling of these products. Plastics that made of PE can contain residual of monomers and process additive. The authority should evaluate plastics and the additive used in them at the temperatures they are likely to encounter during ordinary use, such as heating food in microwave oven. In any problem of the environmental release, industrial spills and release are infrequent, and generally contained. In the event of a spill, the focus is on containing the spill to prevent contamination of soil, sewers, waterways, or groundwater. If a large spill does occur, contain the spill material if possible. In case of fire, keep people away and deny unnecessary entry. Firefighters should wear positive pressure, self-contained breathing apparatus SCBA, and protective firefighting clothing. Use fine water spray or foam. Cool surroundings with water to localize the fire zone. On the environmental issue, PE resins are expected to be inert in the environment. They float on water and are not biodegradable. They are not expected to bioconcrete, or in other words, accumulate in the food chain due to their high molecular weight. Furthermore, PE pellets or granules are not expected to be toxic if ingested, but may represent a choking hazard if ingested by waterfowl or aquatic life. That's all from me. Thank you.